In this presentation, we will discuss the history of the periodic table. By the beginning of the 19th century, scientists had already found many important underlying patterns that made sense of different aspects of the natural world. Chemists were discovering new elements and felt that there must be some natural way of organizing all the elements to reveal how they are related to one another. In this presentation, we will check how their ideas developed until the problem was solved in 1869. Back to the 1820s, a German chemist noticed an interesting pattern in certain sets of three similar elements. He found that the relative atomic mass of the middle element lay roughly halfway between the highest and heaviest elements in the group of three, and he called these groups triads. For example, calcium has a relative atomic mass of 40. Strontium, Sr, has a relative atomic mass of 88, and barium has a relative atomic mass of 137. Which is the element in the triad above, whose relative atomic mass lies almost at the midpoint of the other two values? Is it calcium, strontium, or barium? Let's examine again the relative atomic masses. We have 40, 88, and 137. So yes, the relative atomic mass of strontium lies almost at the midpoint of the other two relative atomic masses. Actually, at this time, many elements hadn't yet been discovered, and some substances were classified as elements that were actually compounds. So it's not surprising that this scientist could only find a few triad groups. The next scientist to suggest a pattern in the elements was the British chemist John Newlands. In 1864, he suggested that if elements are put in order of atomic mass, every eighth element was similar. He called this his law of octaves. There was only one problem. This pattern only worked for the first 15 or so elements known at that time. Fellow scientists at that time weren't very impressed. Some even said that he might have better luck putting the elements in alphabetical order. It was a few years later that the real breakthrough came. A Russian chemist who is called Dmitry Mendeleev was also struggling to find any underlying pattern in the chemistry of the elements. He thought that the key was to arrange the elements in order of atomic mass. But why did the pattern keep breaking down? He spent about 13 years gathering data on the problem and eventually solved it by deciding to leave gaps so that similar elements could always line up in vertical columns. Mendeleev enjoyed playing patience, so he made a card for each element when working out his solution and made lines of similar elements one on top of another. Sometimes he would even have to change the order of a pair of elements to make his columns work. Eventually, he published what he called his periodic table in 1869. It's called periodic because the rows in the table are arranged so that elements with similar properties occur at regular intervals. So this is how Mendeleev arranged the elements. Examine these carefully. Which of the following pairs of elements are not arranged in order of their relative atomic masses? In the box beside the chemical symbol, we have the relative atomic mass. Excellent. So aluminum and silicon aren't arranged in order of increasing relative atomic masses in addition to argon and potassium. At the time, many scientists doubted Mendeleev's theory because he left gaps and changed the order of elements to make his table work properly. However, he won them over by predicting the properties of elements that were as yet undiscovered from the patterns evident in his table. When the element germanium was discovered in 1886, it closely matched the properties Mendeleev had predicted using his periodic table. This showed his fellow scientists that he really had found something special.